In the vast universe of programming languages, Python and Java hold a prominent place. These two giants are like the North Star and the Milky Way, guiding coders through the digital cosmos. Python, with its simplicity and readability, is often a beginner's first choice and a veteran's trusted companion. It's widely used in web development, data science, and even in the progressive field of machine learning. On the other hand, we have Java. It's like a well-aged wine, robust and time-tested, with its roots deeply embedded in the realms of software engineering. Like Python, it too finds its application in a plethora of sectors. Its versatility and compatibility make it a popular choice for large-scale projects. Now, while both Python and Java have their strengths and weaknesses, they are akin to different tools in a coder's toolbox, each having its own unique use. Today, however, we're focusing on their relevance in the machine learning sphere. Let's start with Python, a language that has quickly become a favorite among data scientists and machine learning engineers. Python's popularity in the machine learning realm is hardly surprising when you consider its strengths. Firstly, Python is incredibly simple to learn and use. It's a high-level language with a syntax that is clear and intuitive. This simplicity enables developers to focus on the problem at hand rather than getting bogged down in the complexities of the language. This is especially important in machine learning, where the challenges are often complex enough without adding language barriers to the mix. Secondly, Python's readability makes it a dream for collaboration. Machine learning projects often involve teams of developers, data scientists, and other professionals. The fact that Python code is easy to read and understand makes it simpler for teams to work together and understand each other's work. But Python isn't just about simplicity and readability, it's also about power. Python boasts an extensive array of libraries and frameworks specifically designed for machine learning and data science. Libraries like TensorFlow, PyTorch, and scikit-learn provide pre-written code for a vast range of machine learning algorithms, from simple linear regression to complex deep learning models. This means that Python developers can stand on the shoulders of giants, leveraging the work of others to make their own projects more efficient and effective. Lastly, Python's community is a significant strength. With a large and active community of users, Python developers can easily find resources, tutorials, and support. This community also ensures that Python continues to evolve and improve, with new libraries and tools being constantly developed and refined. Clearly, Python's simplicity and powerful library support make it a strong contender in the field of machine learning. But that's not to say it's without its weaknesses, which we'll explore in the next scene. However, no programming language is perfect, and Python is no exception. Python, despite its notable strengths, does carry with it certain drawbacks when applied to machine learning. Let's dive into these for a clearer understanding. One of the most commonly cited weaknesses of Python is its slower execution speed compared to other languages like C or Java. Python is an interpreted language, which means it tends to run more slowly than compiled languages. In machine learning, where large datasets are the norm and computational efficiency is crucial, this can become a significant hurdle. Algorithms that take mere seconds to run in other languages might take significantly longer in Python, especially as the size of your data scales up. Now let's talk about threading. Threading is the ability of a central processing unit to execute multiple processes or threads concurrently, often improving performance. Python's threading is governed by something called the Global Interpreter Lock, or GIL, which allows only one thread to execute at a time. This can be a major bottleneck for programmers looking to take advantage of multi-core processors for faster execution of their machine learning algorithms. Additionally, Python's simplicity, while a strength in many regards, can also be a weakness. Its easy-to-use syntax can sometimes lead to inefficient coding practices, especially for beginners. This in turn can result in less efficient code execution and more time spent on debugging and optimization. Python's reliance on third-party libraries for machine learning can also be seen as a disadvantage. While libraries like NumPy and Pandas are powerful, they also introduce dependencies that can make code more complex and harder to maintain. Finally, Python's dynamic typing can cause unexpected bugs. Since the type of a variable is checked during runtime, errors can sneak past the initial coding phase and only become apparent during execution. Despite these drawbacks, Python's strengths often outweigh its weaknesses in the realm of machine learning. While it's important to be aware of these potential pitfalls, it's equally crucial to remember that the right tool often depends on the task at hand. Python's ease of use, flexibility, and robust library support continue to make it a popular choice for many machine learning projects. Now, let's shift our attention to Java, a language known for its robustness and versatility. Java has been a mainstay in the programming world for decades, and its strengths are particularly evident when it comes to machine learning. One of the key advantages of Java is its platform independence. Java is a write once, run anywhere language. This means that you can write a machine learning model in Java on one machine, and then run it on any other machine with a Java virtual machine. This makes deploying machine learning models a breeze. Scalability is another significant strength of Java. As machine learning models grow in complexity, Java's robust architecture ensures that these models can scale efficiently. Whether it's handling large data sets or managing multiple threads, Java's built-in tools are designed to handle the load. This scalability is essential for large-scale machine learning applications where data volume and model complexity can be quite high. Let's not forget Java's performance. Java is a statically typed language, meaning it checks your code before it runs. This results in fewer runtime errors and faster execution. While Python might be easier for prototyping, Java often outshines it in terms of performance when running complex machine learning algorithms. Moreover, Java's extensive ecosystem of libraries and frameworks is a boon for machine learning. Libraries like Weka, DL4J, and MOA offer a wide range of machine learning algorithms and tools. These libraries make it easier to implement machine learning models, and they ensure that Java remains a competitive choice for machine learning. Finally, Java's strong community support cannot be overlooked. With millions of developers worldwide, finding solutions to problems or getting help with your machine learning projects is never far away. This broad community support enhances Java's appeal as a language for machine learning. In conclusion, Java's platform independence, scalability, strong performance, extensive libraries, and community support make it a powerful tool for machine learning. While it might not be as easy to pick up as Python for beginners, its robustness and efficiency cannot be overstated. Java's scalability and performance make it an appealing choice for large-scale machine learning applications. Like Python, Java also has its limitations when it comes to machine learning. As we dive into these limitations, let's kick things off with verbosity. Java is a statically typed language, which means you have to explicitly declare the type of data you're working with. This requires more lines of code compared to Python, which is dynamically typed. This verbosity can slow down the coding process and make the code more complex to read and understand, especially for beginners. Java's less user-friendly nature is another factor to consider. While Java can be powerful and flexible, it is often seen as less intuitive and more complex than Python. This complexity can make it harder to learn and use, particularly for those who are new to programming or machine learning. Moreover, when it comes to machine learning-specific libraries, Java falls a bit short. Python has a rich ecosystem of libraries and tools specifically designed for machine learning, such as TensorFlow, Keras, and scikit-learn. On the other hand, Java has fewer machine learning-specific libraries. While there are libraries like Weka and DL4J, they aren't as numerous or as well documented as their Python counterparts. Something else to consider is the data visualization aspect. Java does not have as robust support for data visualization as Python. Python's libraries like Matplotlib and Seaborn make it easy to create a variety of plots and charts, an essential aspect of understanding and presenting machine learning data. Lastly, community support is an important factor. While Java has a large and active community, the machine learning community is more vibrant and active in Python. This means that if you run into a problem while working on a machine learning project in Java, you might find it harder to find help or resources compared to Python. While Java's weaknesses may pose challenges, its strengths can make it a viable choice for certain machine learning projects. So, we have taken a close look at both Python and Java in the context of machine learning. We've seen that Python, with its simplicity and vast libraries like TensorFlow and scikit-learn, is a favorite among many for quick prototyping and data analysis. It's a language that allows for rapid development and testing, which is crucial in the ever-evolving world of machine learning. On the other hand, Java has its strengths too. It's robust, highly scalable, and offers excellent performance, making it a preferred choice for large-scale machine learning projects. Java's strong typing and object-oriented approach can lead to cleaner, more maintainable code. However, the choice between these two languages often depends on the specific needs and constraints of your project. It's not about which language is universally better, but rather which one is better suited for your specific machine learning goals. Whether you choose Python or Java, remember that the best programming language is often the one that best serves your specific machine